first of all, welcome to everyone. It's really wonderful to welcome you all to the third in our Cyprus seminar series. It's lovely to see some familiar names now in the list of participants, and also some new names who perhaps haven't joined us for any of these seminars so far. And given that we've got some new names, you'll allow me to say a few words about CBRL. So CBRL is the Council for British Research in the Levant, and we exist to support and conduct excellent research across the humanities and social sciences, across the Levant region, and to disseminate the results of that research as widely as possible to really promote understandings of the history of the region and the region today. So today is the third in our Cyprus series, and with this series we are thrilled to be collaborating with the Cyprus Institute, which is actually thanks to Thilo and our connections there. The Cyprus Institute is a world-class research and education institute and a regional centre of excellence with a strong focus on science and technology. And for this seminar series, we're bringing you some of the Cyprus Institute's foremost researchers from the Science and Technology in Archaeology and Culture Research Centre. Today, I have the honour of introducing Professor Thilo Rehren. Like several of us here in the audience, I've had the privilege of knowing Thilo for many years and benefiting immensely from his support and mentorship and friendship. So it's a real honour that he's able to join us today. Thilo is A.G. Levantis Professor for Archaeological Sciences and at the Cyprus Institute, and his research focuses on the reconstruction and understanding of the technological processes related to the manufacture of metals, glass, glazes, and ceramics. And for this, he combines concepts and methods developed by the materials and natural sciences in order to shed light on the tremendous achievements of past craftspeople and proto-engineers. And he's certainly influenced an awful lot of us in terms of our outlooks and our careers today. So Thilo is going to be talking to us about Hellenistic to Islamic glass in the Levant, 1,500 years of constant development. This is a webinar format, so please do place your questions in the chat boxes or the Q&A box, and at the end we will hopefully have some time for me to field some of these questions. So I will hand the floor over to you, Thilo, yes, it's over to you.
Thank you so much, Jane. That was a very lovely introduction, and I'm certainly very happy to see that there are interested people in the audience. But also I should stress that, yes, over the whatever 30 odd years, I have benefited myself tremendously from working with my students and my colleagues and my peers, as we shall see as we progress here. So what I present is really not my own thing, but it's a collective achievement and developing picture. So without further ado, let me talk about what happened here in the Levant over about 1,500 years. Before we do that, I appreciate that not everybody may be totally familiar with archaeological glass. So I will give a very, very condensed introduction what glass is. In summary, it's really an extraordinary material, but it is made from very ordinary raw materials. That is sand, just normal quartz sand, which constitutes about 2/3 of the final mass. The other third is roughly ash from some plants or particular salts. Now, mind you, not any salt, no rock salt, but a salt typically known as natron, mineral natron, which is sodium rich and grows in several salt lakes around the globe. And that's more or less it. Then you add in that soup, if you melt it, you can then add a little bit spice to give it color and taste. And those spices, 0.5%, maybe 1% of the final mass, that is a wide range of different metal oxides, which give the glass any color basically that you want. And that is one of the really exciting aspects of glass, much different to what you can do with ceramic or what you can do with metal or plaster, just to mention the other main artificial materials. So it sounds easy, and once you know how to do it and where to get your stuff, it is actually easy. And then you make a very beautiful material, and being beautiful, it is less utilitarian, at least was for much of its history. Today, you can't do anything on your iPhone or whatever without glass. So today it's an absolutely practical material, but it started as jewelry, imitating precious stones, such as lapis lazuli or turquoise or amethyst or carnelian or obsidian, any color, gold, silver, even yellow and white. It has been used for inlays and decoration on quite a grand scale in architecture, but also very delicately in furniture inlays. And then it has been used to make vessels, not your ordinary drinking vessel as we would do today, but quite prestige vessels. And again, imitating gemstones there. I give you an example here. A Roman 1st century cup in the British Museum carved out of natural fluorspar, calcium fluoride, a very beautiful stone, but quite brittle. It very easily cracks and splitters, and chunks big enough to make a big object are pretty rare and expensive. So this is an absolute high-end piece of decoration. And this is a glass vessel, clearly inspired by that layered structure of that fluoride, that multicolored structure, but made artificially in an open form, and more or less you can make as much of that as you like, and it takes not too long to actually create one and another one and yet another one. So we have quite a lot of these type of glass vessels. Another essential background information is the timeline of glass making and the geography related to it. On a significant scale, glass really only emerges from around 1500 BCE and runs through to 1000 BCE, pretty exactly 1000 BCE, both in Egypt and Mesopotamia. Both have created their own glass and have mostly used it for their own internal purposes, but some of it spilled over into Greece. The Mycenaean glass is imported both from Egypt and from Mesopotamia. So 1000 BCE, things stop. Until then, glass was made from laboriously crushed selected white quartz pebbles and the ash of particular plants growing in the desert or on the seashore. Around 1000 BCE, some clever person realized you can actually use the natron from the Wadi Natrun that the Egyptians had been used throughout their written history to mummify each other, to make detergents for laundry, for medicine, and so on. And then they discovered, oops, you can make glass from it if you melt your quartz with the ample supply of natron rather than plant ash. The problem is the resulting glass is not stable over a generation or two once it gets into the wet ground. And despite Egypt being a desert country, there's enough rainfall and Nile inundation and so on. So the glass produced from then onwards, I believe, was produced, but simply didn't survive archaeologically. We only see glass surviving roughly half a millennium later in classical Greek contexts. Now, the crushed quartz pebbles seem to have been replaced by sand, less clean, but therefore containing calcium oxide, which stabilizes the glass. So here we see it now surviving. In between, there were just glass beads, black glass beads mostly, stabilized by the iron content added to make them black, but that's about it. And then we see that glass, mineral natron-based glass, continuing through Greece, Hellenistic, Rome, into Byzantium, while at the same time in the Sasanian Empire and its predecessors and successors, so in what is today roughly Iran, we see here in green, therefore, the plant ash glass continuing. So we have a split into two parallel running material traditions. At 800, 900 CE in the Levant, the mineral natron glass making finishes, ceases. I'm not quite sure why. There are different explanations for it, but we see a seamless continuation of large-scale glass production, but again built based on plant ash. Quite likely that with the expansion of Islam into the further Western Asia, that they simply allowed that plant ash tradition to come back and supply even Egypt now with plant ash-based glass. So we know a lot about that from chemical analyses. There's 10 lectures worth of stylistic development compressed in this period, which I'm not going to cover. There are far better people for that, and fantastic literature. Glass is just so beautiful. And with that working ability, that coloring ability, as an artist, you can really do fantastic things with it. But I'm not an artist, I'm a proto-engineer, I'd say. So I'm more interested and will continue now talking about the glass making, how this glass had been made. And there we know amazingly little. Why is that? In that whole region here, the geography of ancient glass, that entire region for centuries was not flooded with, but had an abundance of glass, natron glass, plant ash glass, and we have hardly any idea where it was made, how it was made even. We are chipping away little by little on that question, but we have very little hard evidence archaeologically. And that is weird. I came into glass making from archaeometallurgy, where I grew up with slag heaps that are measured in millions of tons of slag thrown away for thousands of tons of copper production. So I was used to the idea that primary production really should leave a strong archaeological footprint, but no, it doesn't for glass. Why is that? Now, glass actually is an additive material, not addictive, that it may be as well, but it's an additive material in that the two raw materials, the quartz, the sand, and the flux, the natron or plant ash, are fused together to make glass. So not as in metal production, where you take a big chunk of rock and ore and you pull out a little bit of metal and throw away all the remaining slag. Here you fuse things together, you get your glass, and that's it. Now you see that little white layer on top of the glass with the term gull on it. That is a little bit of waste because the flux that you add, whether it's plant ash or mineral natron, does contain 5, 10, 15% of rock salt in addition to the actual soda. And that rock salt and similar stuff does not react to make glass. That simply forms a separate melt on top of the molten glass, like a little bit of fat on a thick soup or something. And that gull, you simply skip off, or it flows off, it gets absorbed by the furnace wall, whatever happens, it is salt, rock salt more or less, and as such, the next rain and it's gone. So we don't see that archaeologically either. We only have the glass and maybe that installation of a furnace here. So that's why glass making leaves so very little trace in the archaeological record. Now, I mentioned the use of sand for glass making, and in the area of interest, there's plenty of sand, and not just sand, but quite different sands. And that becomes important. So if there is no trace, no waste left, but the additive material is there, that means that all the dirt that comes with the sand as part of the sand is still in the glass. And that's why, in particular, ancient glass looks a little bit greenish, bluish because of that whatever dirt that is in the sand. And that dirt is characteristic of the origin where the glass has been made. Now I have a child, it's grown up now, but if I look at children and they come home having played somewhere, you can see from the dirt where they had been playing. So in that sense, I can say the one on the left that was playing in the mud, and the mud is down the road where the fields are, and the other was with the sand, was playing in the sandbox, and that's next to grandmother's. So you can provenance dirt quite easily. And that is how we understand now the Hellenistic, but also in particular, the Roman and Byzantine glass industry. We take the glass object, we analyze them, and we sort them by the sand from which they were made. Because the flux, the natron, that mineral sodium carbonate, that by good chance is the same for wherever the Romans, the Byzantines were making glass. Now, parenthesis, there's a discussion about that as well. Let's not go down that road. That would take another 15 minutes. But in principle, the flux is pretty much a constant. So any variable within the within the glass composition is due to the sand. And when these salt lakes dry up, you can simply harvest those drying salt cakes, salt carbonate sheets, break them, put them on the back of a camel, and down the road you go and bring it wherever it's needed. Has been going on for thousands of years, continues to this day. And as a quasi-mining operation, it's much more productive, large scale, than the difficult burning, collecting of specific plants, burning them, collecting the ash and using that to make glass. That was feasible in the Bronze Age when you had Pharaoh paying for everything and you needed 5 kilograms a week. But if you need to supply the Roman Empire, that's just not on. Instead, we see fantastic large production sites. The excavation squares in the back, I think, are 5 by 5 meter. And that row of footprints you see in the middle of the picture are the basis of individual glass making furnaces. I think there's a dozen and a half or something like that in that one site here in Israel. Each of them was fired. The operation probably takes a month to fire one of these. And then you let it cool for another 2 weeks, and then you break it up and you build the next kiln right next to it and make the next firing. Why do we know that? Because one of those blocks did survive. It's here in this photograph. It's in a cave and as such well protected. I'll give you the next picture so that you see that human here for scale. That whole block, it's about 20, 30 centimeter thick. and the size of a very comfortable triple bed, I would say. It's 8 to 10 tons of glass, a single firing, enough to make roughly 60,000 glass vessels. So you don't make 60,000 glass vessels in such a site in the middle of Israel and then ship the vessels. That doesn't make sense. They break, half of them, on the route to York or Paris or wherever, London, you want to have them in the Roman Empire. So you ship them in a different form. What I want to show here is just an example. The first two lines are the composition of the actual glass, the sodium and the silica, soda and silica. That is what really matters. Everything below is that variable dirt in the sand. Depending on what sand you have, you get this or that. And you see here 5 different compositions as examples, thanks to Ian Freestone. And if you look at the aluminium content, they are between 2 and 3%, relatively similar. But if you look at the iron content, that varies much more, from 1/3% to 2%. Lime between 5, 6, 7, 8, 10. So you can get decent separation based on the dirt in the glass, which is a geochemical coincidence. But luckily, most sand deposits are within themselves reasonably consistent. The first 2 lines, they reflect human agency. They reflect the recipe that people have actually used to make the glass, the mixture, how much of this, how much of that. So once we know that, we plot these different, we take our analyses, we plot them, and we get different clusters, and then we give names to these clusters. And for most of them, we have no idea where they were made, but we can characterize them, which is nice. What is also very nice is that even though there's a dozen or 2 of those major glass compositional groups, at any one given time, there are only 2, 3, maybe 4 active at the same time, supplying a vast area of the Roman Empire. So we can, if we have a reasonably good dating grip on our material, with the chemistry, pretty much identify to which group an object belongs. Here is a picture of these glass chunks, the broken up big tank furnace. They were shipped, literally shipped, across the Roman Empire. We find them in Britain, we find them in Spain, we find them in the Balkans, we find them in Egypt. And once analyzed, we can link them back to those few production sites, either in northern Egypt or in the Levantine coast. These blocks, once they arrive in York, literally in York in England or wherever, Germany, you put them in a little crucible, in a little kiln, you fire them to 800, 900, 1,000 degrees, and then you blow and make whatever vessel you want now, near to your customer. And then those 60,000 vessels are not all sitting in Israel, but they are sitting in all the different shops across the empire where they are then sold to the customers. So that's how we understand the organization of the Roman Byzantine glass industry. Just as an example, and here's a clear shout out to Fatma Marii, whose PhD this is reflecting. She was looking at glass from the Petra church, and you see Petra here on the right-hand side, situated closer to the Levantine producers and quite far from the Egyptian producers. And so we wanted to know, where do all these glass lamps come from? Plenty of them surviving archaeologically, pretty much more or less the same. It's the bottom part of these hanging lamps. And as a church, a major building project, they need a lot of them. So it was not a surprise that they more or less all fell into that Levantine compositional range, which means that Petra, big building project, Petra churches, they needed, I don't know, thousands of lamps and windows, and they got the glass for that from the next local large producer. Makes perfect sense. If you have a large order, you get that very homogeneous glass. Now, we also looked at the monastery of Derenabata, a little bit further north, even closer to the Levantine glass-making sites, even further away from Egypt. But there the picture was much more complex. The black triangles are the analyses of glass objects from that Derenabata monastery. And you see, yes, the majority are from the Levant producer, Levantine one, but there are quite a few others, including at the bottom and on the right, on the left, Egyptian glass. And that was nice because the local archaeologists knew, oh, that monastery actually had a lot of pilgrims coming from Egypt, historically documented. And it was a poor monastery, and pilgrims might well have brought a glass lamp for donation to the monastery when they came visiting, so that monastery accumulated, like a good student household, pots and bits and pieces from here and there, rather than having one big order. So one can, with these chemical analyses, do quite a bit of nice archaeometric research and put that into their historical context. So in terms of the roughly 1,000 years of Roman to Byzantine glass industry, the key message is we group the glass compositions by its underlying sand. There's a limited number of huge scale production sites which run for 100, 200 years each, dependent on the imperial trade network to distribute these vast amounts of locally produced glass. And once Britain, the Brexit from Rome happens 410 or when, you don't get fresh glass anymore in Britain. So all the Romano-British glass is the Byzantine glass is more or less absent from Britain, but it's quite happily still present in the Balkans and the core Byzantine Empire. And that transported glass was then locally reworked into objects and of course recycled as often as needed until it was buried and lost. So that's very roughly what the Roman Byzantine people were doing. There's an interesting story behind there on the color of those different glasses, which also changes over time and has been manipulated as well as naturally left colored. But again, that would lead too far, but it shows again changing tastes and changing priorities of the customers. All of that beauty ends in the 8th, 9th century CE. For whatever reason, mineral natron supply seems to have stopped. Climate got wet. People were unhappy in the delta. The transport was interrupted. I don't know. But we see from that roughly 100-year period a pretty reasonably quick and fundamental change back to plant ash glass making, shortly after the spread of Islam. Now, glass has no religion, but for convenience, traditionally we call it Islamic glass because its spread and coincides very much with the spread of the Islamic empires and their internals, ups and downs. Here now, what we see is actually the plant whose ashes were used to make the glass. In addition to the sand still is an important element. We see fantastic, beautiful objects. So, when you give me this glass, I couldn't say whether it's natron or plant ash. I just say, oh, wow, looks beautiful. But you would need to analyze this to see the difference between natron or plant ash. I want to illustrate briefly one point by showing you one of the very few, maybe a handful, known Islamic glass making sites. This one, pure chance that I got involved in Eastern Uzbekistan, which is very much on the northeastern end of that Islamic influenced glass country area. So doing field work there, looking at crucible steel making, actually. I said I'm an archaeometallurgist originally. This is the site of Achsiket, an aerial view, a kilometer square, roughly, not square, obviously, but, and you see on the right-hand side these dots along the city wall. They were the leftover mud brick fortification towers. You see in the lower left corner the inner city wall. Now they ran down the outer fortification because they were living in a stable environment, politically, economically, in the 12th century, or so they thought. 1220, the Mongols came passing by, and that's what's left from that visit. So it's a major excavation site of the Uzbek Academy of Sciences with Dr. Abdulhamid Anabayev and later Dr. Fahad Maksudov leading the excavations there. And where that little arrow points, that is where there is an glassworks that we found propping out on the surface. The paths there are trodden by local villagers, football playing kids, and four-legged animals. And there we found this sort of stuff. Furnace wall fragments with glass chunks on it. You see that greenish color, bluish greenish. That is typically from the iron content in your raw materials. You see these drips and drops, which is exactly what the glass worker pulls out from the liquid glass crucible to test, to run it through their fingers. Is it fully smooth, molten, or are there still sand grains in it, or pulling out drops of ceramic that fell into it and throwing them away to not contaminate the glass. So very clearly a glass furnace, a glass making furnace. Here is a cross section through a mud brick in the lower left corner with plaster, mud plaster, calcareous plaster on the top and the right, and that little leftover of glass where it had been melted and then taken out while liquid. So that sort of Central Asian Islamic plant ash glass has a much wider chemical variability than the Roman Byzantine one. In this graph, magnesium versus potash, in the lower left corner, you see a very tight cluster. That's basically your mineral natron glass. And then in the center and in the upper right part, it scatters all the Islamic, the Sasanian and the Syrian and this and that. Because you now have a much more variable sand, you're not just taking the sand from that little strip in the northern Egypt and the Levant, but you are taking sand from across Western Asia, Central Asia, and you add the variability of the plant ash, which actually brings the magnesia and the potash, most of it. And these plants, in turn, reflect the soil's chemistry on which they grow. So you really have here a massive mess of composition. And you see also that the clusters are not at all tight. They're very scattered and overlapping each other. So that nice game that we did, or research it's called, previously, is not really feasible here anymore. Just another projection, magnesium versus lime, alumina. It's much more variable, which in theory should be nice, because you should hope that you can, because you have more variability, you can better identify different groups. But since each group in itself is rather variable, all we can do is very broadly assign wide regions, but not individual production sites. Marcel Franken, a current PhD student of mine, pulled this map together. You see the Levant on the far left, and you see the open circles. Those are the known primary natron production sites, and you see how tightly clustered they are. While in the red diamonds, you have assumed known primary plant ash glass production sites, and they scatter up to Arsiket in the northeast corner. And then all the black dots are consumer and secondary sites. So we see it's much more spread out, the production and the working. And a lot of people have, very intelligent people, have analyzed a lot of glass samples with very expensive and powerful equipment, laser ablation, ICP-MS, and whatnot, and formed compositional groups, defined them, and looked at which group is where. And it's, well, it's a very interesting pizza presentation here, more than quadrostazione, I would say. And there's no real picture, at least not visible to me, emerging here, which I think means that this old tool, the tool developed for the very neat Roman Byzantine glass chemistry with few reasonably well-defined clusters, that traditional tool just doesn't work for this much more dispersed, much more variable Islamic glass composition. So we have to come up with some other clever ideas if we want to understand how that Islamic glass industry was actually organized. Also bearing in mind that even if I say the Islamic, the empire was not that big homogeneous thing. It was much more fragmented. The big empire didn't last too long. So we have to contend with countless local and regional production centers. Even a small-ish town, city like Arsiket on the fringes of the known world made its own glass. Not like York importing the good Roman stuff, but making it for itself. Very variable sands, very variable plant ashes. But interestingly, the workshops were integrated. One and the same workshop was making the glass from raw material and producing the finished object. And that is why that workshop in Arsiket is situated where it is, on that inner city wall where everybody has to come through. It's a perfect spot for a merchant to sell glass. You have lots of customers that have to pass by your shop. Glass is still beautiful. You can still sell it there very nicely. So to illustrate the scale of a workshop that is needed to make glass and glass objects, I give you this 16th century picture here. It's a float. It's on wheels. It's like a carnival float. It's a parade in front of Sultan Murad III, where all the different crafts are presenting their trade. And here they have, on a float, on wheels, a fully functioning glass furnace. And you see the glass blown, the yellow on the lower left corner, the yellow glowing soft glass, which is being swung around to make that elongated vessel shape, which the gentlemen in the back are then holding, obviously cold by now. It's just amazing. Here it's a close-up of that. They are blowing the glass, they're working it on the go. That's all it takes to make a glass furnace that fully works. Or in Herat in Afghanistan last century, 50 years ago, just people making their own glass, going on a weekend for a stroll to collect the quartz pebbles and the plant ash. The plant ash actually you get from the market because it's still a useful commodity, was at the time. So interestingly, the same concept happened in Europe at the same time. As we see in this, I think, 14th century picture. Sand being dug up in the background, trees being grown systematically, very regular tree growth to cut down to make wood ash, and then down here the furnace, same shape, same size as the Islamic furnaces, even though this is in Central Europe, to blow the glass and make vessels, which are then inspected on the lower left corner and traded on for the market. So all that medieval glass industry is much more chemically variable from both the sands and the plants. And you have countless production units at any one time. So that whole provenancing business, I think, is a little bit pushing it now. Of course, there were some large-scale units. There were still massive producers that we see, in particular in the early Islamic period, elite-controlled, linked to palace building, linked to making gift exchange objects and such like. But overall, it's a very regionalized glass-making industry now and based on these integrated workshops, not separating primary production from secondary production. So now it doesn't get boring. There's a Byzantine glass industry in addition to those two main industries that are widely known and that I presented so far. This material we only came across about 15 years ago, thanks to a colleague in Berlin at the time, Schwarzer, who was working in Pergamon in Western Anatolia. And Holger spent, I don't know, 3 years as a postdoc looking through the glass collected over 100 years of German excavations in Pergamon, covering from the Hellenistic right through to the Middle Islamic period. And he got permission to export 100 samples for analysis sorted along the timeline. Pergamon, just for comparison, is here in Western Anatolia. That is a kind of glass that was present there, glass chunks, waste objects, so clearly production working, but also lots and lots and lots of nice broken objects. Actually, he documented individually 20,000 glass objects, 0.5% of which he was allowed to sample and export, half of them from the early period, so that Hellenistic to Roman, and the other half mostly early Islamic. Nice analysis done. Nadine Schibille did her master's on that. Philip Connolly did work on that material. I worked on some of it. And we did the usual approach. You take that underlying graph, you bow your head in appreciation to Ian Freestone for creating it, and you plot where does your glass fit so that you see which producer you have. And you have your antimony decolored and your manganese decolored and your cobalt blue and the Levantine and so on. And that's fine. Nothing too exciting happened here. I want to point out in the lower right corner the 4% alumina. Typically, that Roman Byzantine glass, as I mentioned earlier, has 2 to 3% alumina. It's part of the sand, and 6 to 10% lime, which is needed to make the glass chemically stable against weathering. Then we kept analyzing. So this is all the early and middle period up to the 5th century CE. And then we got into the late glass, that early Islamic, 9th to 13th century. And look at that alumina, 12% at the end of the axis. These glasses have 5, 6, 7, 8%, 10% alumina. Very different composition, nothing to do with the typical Roman Byzantine glass anymore. And also not your typical Sasanian or Mesopotamian glass. The lime content is kind of there, but the alumina is much, much higher. So we kept analyzing, and thanks to laser ablation ICP-MS, we got hold of these funny trace elements, lithium and boron. In the lower left corner, you see all that Roman early glass. They have basically no lithium and maybe 200-300 parts per million boron. 300 parts per million would be 0.0%, 0.03% boron. So very, very little. You really need good analysis to catch it. These glasses have 800, 1000, 1600 ppm boron, 200-300 lithium. It's a very different raw material. Both the alumina, which we suspect comes from the sand, and these two elements which are clearly linked to the flux, they're totally different. So we went out and published it and defined the HBAL, the high boron, high alumina, and the high lithium boron alumina glass. And with a bit of background research, quickly discovered that Western Turkey, and that's pretty much the region around Pergamon and Sardis, holds 70% of the world boron reserves. Boron in glass today is totally common, large percentages. All your Ceran fields in the kitchen, all that borosilicate glass that you can put into the microwave, it's all based on 10-20% boron. And that's where Turkey is a massive production leader. But obviously 200 ppm, 300, 1000 makes no difference in the quality of the glass. But obviously, given that that glass comes from that region, was first discovered in that particular region, I think the argument is plausible to say that this is regionally produced glass, not your typical Egyptian or Levantine glass. So we suddenly see here a further production region. That's how these boron works look like. They do resemble the mineral natron from the Wadi Natrun, from the Salt Lake, because it's the same kind of mineral. The question now is, when actually did this glass production start in Western Anatolia? And how important, how large scale is it? Is it just a local, serving local needs, or is it more of regional, including export significance? And what actually were the raw materials? Was it mineral boron as part in the sand? Or was it dissolved boron salt that the plants would take up? Was it a bit of both? We honestly don't know. There's not a faint trace of a production site in common with all the other glass-making sites that I mentioned earlier. We have hardly any evidence for the physical evidence for the making of the glass, other than that the glass is there, obviously. Now, it clearly is a regional production, since we discovered that in 2011, I think. I have seen it, people have seen it routinely now, if only they analyze for lithium and boron, from Romania through Bulgaria, through Turkey to Syria, to the Turkish-Syrian border region. Not in vast quantities, but in individual churches, you may have half the window glass being of that type, or 30% of the glass bangles, or whatever it is. So it is a significant regional material. Importantly, it coexists with mineral natron glass and plant ash glass, obviously the natron glass in the earlier periods. And going through the literature and seeing what other people have analyzed before this material had been formally recognized, I think an argument can be made that even in the Iron Age, we see already suspiciously boron-rich glass coming up in that area. So it could well be that there is a long-standing local regional glass-making tradition in Western Anatolia. I hope very much that we keep analyzing with laser ablation ICP-MS glasses from various periods in that region to see how long was that actually in production. Now, after the 1500 roughly, I find it very, very difficult to find any information on glass making in the wider Levant. Clearly, I assume it continued. I came across a brief note the other day that in Hebron, glass, and the Hebron glass is very well known, quite rightly, for its beauty and its production, that there in the 18th, 19th century, glass making still took place with imported natron, but it was in a tertiary source, and I couldn't get to the origin of that statement. It may well be plant ash, but even if it were plant ash, it would be nice to be able to say Hebron was making its own glass, as we know it, from Herat in Afghanistan, thanks to Bob Brill and his team in the late 60s, early 70s, documenting glass making there the traditional way. But as I said, very little evidence after 1500 must have gone on. About 2 years ago, I was invited to give a lecture in Haifa and was shown, because the locals knew that I'm interested in glass, was shown the glass works of Mitzgaga, just south of Haifa, right on the shore where Tel Dor is, which is an industrial, late 19th century industrial ruin, now shaped as a museum, thanks to the local curator, Bracha Silverman. That glass factory was set up in the 1890s on behalf of Baron Edmund de Rothschild to produce bottles for the wineries that he had set up on the Mount Carmel. So he needed glass bottles. There was no substantive glass production, and he wanted to industrialize Palestine as part of that Zionist drive to colonize the Palestinian coast. That is a building that survives. These are surface stray finds collected with permission because it's not old enough to count as antiquities, and the curator was very interested and supportive. So on the left-hand side, we have object fragments, and on the right-hand side, we have glass waste, obviously molten, disformed blobs and blips, which we collected. And then Giulia Fogarizzu, a good student of mine, analyzed that material here in the Institute, and we were lucky and just published it a few weeks ago. Among all of that material, as I said, surface finds, the ruins had been left open for half a century at least, and people were partying there and drinking beer bottles from modern beer and Coca-Cola and whatnot. So there was modern glass among that as well. What we wanted to know, can we identify first the actually locally made glass in Mitzgaga? Then can we identify what sand they were using and what natron were they using? Remember, at that time, Palestine was part of Syria, of the Ottoman Empire, the Syria province. The same administrative province included even the Wadi Natron in Egypt. So it would have been economically, politically very easy to get natron up the coast to Haifa, to Tel Dor. There is an anchorage. and bring in the natron from Egypt, or where they're using European chemically made soda in that drive to industrialize and that belief in modern is better and all of that crap. So looking at the sand, we look at the elements, the trace elements that reflect the sand. We knew from Roman Byzantine work that Levantine sand is different from Egyptian sand. The Egyptian sand here are the round green blobs in the center at the bottom, and the other ones, the crosses and X's, are the Levantine sand. And you see very nicely how the so-called main group, waste and objects from Mitzgaga, plot very nicely onto the local Levantine sand. The orange ones are other objects, which are those bottles of 20th century beer and whatnot, which were broken and scattered in the grounds of the museum. Looking at the soda to calcium, we noticed that both elements are elevated compared to both Egypt and Levantine glass, which is interesting because the sodium, the soda, is the amount of soda clearly reflects, as I mentioned earlier, human agency. The glass worker decides how much flux, how much soda they add to the melt. The more, the higher the soda goes. But remember, that's also the expensive bit. And similarly, lime in modern glassmaking is an intentional addition. It's part of the recipe. It's not part of the dirt anymore, as it was in Roman times, part of the sand. In that ternary projection where we plot the three main components, lime at the top, soda on the one side, silica on the other corner, we can very nicely see how that blue-colored Mitzgaga modern glass is clearly richer in soda than all the Roman, Levantine, Egyptian glasses. And it's nothing to do with temperature. Clearly, modern furnaces were able, they were operating with mineral coal. They were able to get much higher temperatures than the Romans would have. So why did they choose to have a more soda-rich recipe? We come back to that in a second. I just wanted to show here that chlorine versus boron graph. Those light scatters in the top are all the archaeological Levantine Egyptian ones that we had taken for comparison. Roman glass has around 1% of chlorine. It's just that little signature from that salt that I mentioned earlier that is part of the mineral natron or the plant ash. Both are salt rich. And the boron, you see how little, 50, 60, 100 ppm boron, much, much less than that boron-rich Byzantine Western Anatolian glass, but clearly more than the glass from Mitzgaga. And if you analyze modern glass that is not intentionally boron-rich, they don't have much boron in their glass because they use a chemically produced soda ash Solvay process or whatever, and that just cleans everything out and gives a pure sodium compound. So I think we have good reason to argue this factory was importing its soda from Europe because there were no chemical factories in Ottoman Syria at the time, but used the local sand, which kind of makes sense. But that industrial European imported soda was clearly expensive. You have to get it onto a ship in Marseille and all the way down across the Mediterranean to Teldor, to the anchorage, to offload it. Now, Baron Rothschild is probably financially capable to pay for that, but still the factory itself only operated, I think, for 4 years, and then they packed up. I don't know the history enough to understand why, but research is ongoing in collaboration with the curator. But why that soda-rich recipe? Why would they do that? So we pulled together, and again, Giulia Fogarizzu was very instrumental here, comparative glass analyses from that period, late 19th century. And you see these others, they all sit in that long trough near to the more silica-rich end, where the Roman Byzantine glass was also sitting. So it's not that Europe shifted to a more soda-rich recipe. That is a very unique Mitzgaga signature. Why? You look at the melting temperatures, they are the same, 1100-1200 degrees. Nothing out of the ordinary. After a bit of rummaging in the library online, it became clear that that more soda-rich composition is much softer, much easier to blow. And there is a lot of occupational health literature out there on the lung capacity and the lung diseases of professional glass blowers from the 19th and 20th, early 20th century, before glass blowing became an automatic process powered by engines. As long as you blow your glass by hand 8 hours, 10 hours a day, you get a very strong chest muscle to blow hard, a big volume. Now, those European Zionist colonizers of the time, they were not likely to be experienced glass blowers, were they? They were people of any trade, but they found work in the glassworks. And for them, it would have been much easier to blow a more soda-rich glass into bottle shape than the much stiffer silica-rich glass. I have no idea whether that is a true story. It's just a plausible explanation. I put it out there. We have put it out there, Giulia and I and colleagues. But it's something to consider when we think why people take decisions about recipes and working conditions. The practicalities matter. And here then the interplay between, yes, it's a glass that even an inexperienced glass blower can work, versus a glass where the raw material is not too expensive. So, in summary, for the last hour that I gave you, overall, we know extremely little about glass making in general because of it being this additive material which has hardly any waste left. For much of the time, we have a constant natron source, but changing sand. Now, I didn't discuss it in any detail, but if you think, why would they change after 100 or 200 years? Why would they move on to a different production? The sand deposits are big enough. The natron kept coming from Wadi Natrun. Why would they move the production sites in that almost regular 100, 150 years? Now, if you look at what determines the positioning of a glassworks, it is the availability of fuel, of wood to fire the furnaces. I mentioned these huge tank furnaces. They take a month, 24/7 firing at a very high temperature. You push your trees from the Lebanon mountains through those furnaces, no end. And at some point after 100 years, you have simply exhausted your fuel supply within walking distance, and you have to upstick and set up a new glassworks elsewhere where you still have enough trees to chop down and or agricultural waste or whatever to actually maintain your furnaces. But that large-scale, massive production obviously has a massive investment behind it of capital, of labor, of logistics to move the raw materials, of logistics to distribute the materials. We have very little idea who actually organized all of that. There were a few regional producers now propping up independent of the Wadi Natrun natron in that period. I mentioned the one in Western Anatolia, that boron-rich one. Daniela Rosenow and I are working on narrowing down a plant ash producing region in southern Egypt, maybe early northern Sudan. In that period, they are too far away from the Wadi Natrun. They would have continued their local plant ash making. So there is some smaller industry still existing. And then at the 8th, 9th century, 9th, 10th century, it flips back to plant ash-based production, and it quickly disintegrates into much more small scale and much more regional, even local production units. These integrated workshops, which sit in the city where they produce glass from raw materials in the morning, blow it in the afternoon, sell it in the evening, and the next day they start again. Now the end product of all of those glass makers looks amazingly similar. The raw glass as such. You can't really tell apart visually unless you are very experienced what type of glass it may be. And with that, I would like to say thank you very much to you for your patience and listening to me, but also to the AG Leventis Foundation, whose sticker I have put on one of those glass bottles from Pompeii, just to show how the range of natural colors in natron glass can vary from one vessel to the other. Thank you very much.
Thilo, thank you so much for such a wonderful presentation. As always, you've made a subject very, very clear and given us some real food for thought. So thank you for that.